Hello everyone, in this video we're going to look at modular code. So in particular how we can write methods to perform common operations. Now the reasoning behind this, it allows us to reuse code over and over without having to rewrite it each time you want to do something. So writing little methods like this are really useful when we're writing code. Now the methods we're actually going to implement are, we're going to write one that calculates the greatest common divisor of two numbers, and we're going to write a method that tests whether a particular number is prime. So, let's get started. Over in Eclipse, I've created a new project called Modular Code, and we're going to right away add a class to this. Now, I'm going to call this class Greatest Common Divisor Method. Greatest Common Divisor Method. And we won't worry about the main method just yet. So let's hit Finish, and here's our class. And I'll maximize this to give us some space. So, right now let's get started with our method signature. Now, this is going to be a public method, meaning that any code can call it, and it's going to be static. The method's going to return an int, which is going to be the greatest common divisor between the two numbers. So the method name is going to be GCD, that stands for greatest common divisor. Now the parameters to this method are going to be our two numbers, so it's going to take two integers, int n1 and int n2. Okay. Now that's complaining because we have said we're going to return an int, but we're not yet. Okay, so we can ignore that error just for now. So the first thing we're going to do is create a new variable called GCD, and we're going to initialize this variable to 1 to start with. And next, we're going to have another variable that's going to serve as a temporary variable as we're calculating, and we're going to call this one k. And we're also going to initialize it to 1. Now, the next thing we're going to have is our while loop. So while, and the condition for this is k less than or equal to n1, and k is less than or equal to n2. In other words, we're looping as long as k is smaller than both of our numbers, n1 and n2. Okay, now inside the loop we're going to have a comparison, and what this comparison is going to do is test whether k cleanly divides n1 and n2. So the way we can do this in code is to use the Modulus Operator and test whether the answer is 0. Remember that Modulus tells us the remainder as if an integer division took place. So if the remainder is 0, that means that k cleanly divided n1, for example. So let's put this into code now. If n1 %, k equals 0, in other words, if the remainder, if n1 was divided by k is equal to 0, and, because n2 modulo k equals 0, because we need k to be able to divide both of these numbers. Okay? Alright, so what we're going to do here is simply update GCD and set it to k. And just before we end the loop, we're going to increment k. So we need to do this because we want to find the greatest common divisor. So 1 is kind of a simple one. We know that 1 will work here. But we don't know if that's the largest one, so we keep looping for as long as we can. Now, that's the end of our loop. So all we need to do now is return the greatest common divisor. So by the time we've gotten to here, we've calculated the number that we need, and we can just return it. So return GCD. And that's our method. This will calculate the greatest common divisor of two numbers, which is great because we can use this to find out the common divisor, and we never have to write this piece of code ever again. We can just call the method, so it makes life a lot easier for us. So now let's quickly write a main method to test this. So public static void main string array args. Okay, now something I should mention is we're going to read in input from the user, so we better import scanner. Import java.util.scanner. Alright, so back in our main method now. Let's create our scanner object. Scanner input equals new scanner, and of course we're reading from system.in. Oops. Okay, now we're going to get the user to enter 2 numbers. So we better tell them that. Enter first integer. I can type this morning, I swear. Actually, this won't be print line. We'll just keep this on the same line for now. Now we'll read in the number. So int n1 equals input dot next int. And I'm just going to copy paste this code. Enter second integer, and we'll call this one n2. Okay, so now we're just going to print out the greatest common divisor of these 2 numbers. So system.out.print line the greatest common divisor for. Now we're going to do some string concatenation here. N1 plus. Now we'll go down onto a new line here. And plus N2 plus is. And this is where we're going to do our method call. So plus GCD N1 N2. And that's all we need to do. So we've written a method that calculates the greatest common divisor, and we're testing this. So now let's run this to make sure it works. Run as Java application. Yes, we'll save this. Enter the first integer. So let's enter something simple. So 50 and, I don't know, 15. The greatest common divisor of 50 and 15 is 5. And that's correct, which is fantastic. So now, let's do our prime number method. So what we're going to do here is create a new class, and I'll call this one prime number method. Okay. So what we're going to have here is test whether a number is prime. So public static method. Now this one's going to return a boolean, either true, yes it is a prime number, or false, no it isn't. So is prime, and it's going to take a single int as its parameter, and we'll call it number. Alright, so what we're going to do here is test what numbers can divide this number here. So we're going to have a for loop here, int divisor, and we're going to start this off equaling to 2. And we're going to continue until divisor is less than or equal to number divided by 2. So we're only looping halfway up the number, which makes a lot of sense, because once we get halfway, it's symmetrical. It doesn't matter if we're doing 6 times 3 or 3 times 6 as the factors. They're the same, they're just around the other order. So we don't have to loop to the whole length of our number. So length, well, it's number less than number divided by 2, and divisor plus plus. Okay, so if we're going to use the modulus operator again, number modulo divisor equals 0, return false. So if we found a number that cleanly divides, if we found a divisor that cleanly divides number, we're going to return false. If we get all the way through this loop here, then we're going to return true, because we didn't find a number, a factor for this. So that means that it is prime. So what we're going to have now is, let's do something different. Let's write a method that prints out the first X number of prime numbers. So again, public static. Now we're not going to have a return here. It's just going to be void print prime numbers. And this one's going to take a parameter int number of primes. So the number of primes that we're actually going to print. So we're going to declare a final here, int number of primes per line, and we're going to set this equal to 10. So this is just how many numbers we're going to print before we have a new line character. So next we're going to have int count equals 0, so how many we've printed so far. int number equals 2. Alright, so we're going to have a while loop here. While count is less than number of primes. So until we've printed out as many as we say we're going to print, we're going to increase the count before we forget. So if count modulo number of primes per line equals 0, we're going to print out a new line character. So system.out. And we're going to use printf, I think, this time. So we're going to do a formatted string. So %-5 s \n, so new line character. And then we're going to print out the number. And I've forgotten something. If, oops, not there. We forgot to check whether it is actually prime. So up here, if is prime number. Alright. Let's format this and make it correct. So if the number is prime, then we're going to increase count. Now, what this is saying is if we've reached the number of things that we said we're going to print on a line, then we're going to add a new line here. Otherwise, we weren't going to, which is going to be our else. Else, we're just going to have this print statement here without the new line character. Okay. If it's not prime, we're just going to increment, well, we're going to increment number regardless of whether it's prime or not. Number plus plus. Okay, so this is going to print out the number of primes that we tell it to print. So let's test this as well. So just a simple main method now. So public static void main string array args. Now system.out.println. The first, I don't know, let's print out 50. Numbers are, and we'll put a new line character here. So we get a gap. So print prime numbers, we're going to call our method and we're going to print 50 of them. So here we're using two different methods, and including our main method, 3 different methods. So the first one just tells us whether a single number is prime or not. The next one prints out a bunch of prime numbers depending on how many we tell it to. So finally our main method is using this to do something useful. So let's run as Java application, and there they are. The first 50 prime numbers are all of these. So if you're wondering what this %-5s means, that means the number of blank lines to pad. So if we run this again, you can see that this is nicely formatted with up to 5 characters. So that's how we do nicely formatted text using printf. So with that, that's pretty much for this video. So what did we do? We wrote some methods, and these methods allow us to reuse common sections of code. It means that we have less code to write because we can reuse sections over and over, and it also means that our code can be more robust because we can actually test these methods rigorously to make sure they do what they're supposed to do. Whereas if we're either copy and pasting code over and over or just writing it from scratch over and over, we never get to do this amount of testing. So the methods that we actually wrote were the greatest common divisor, which took 2 numbers as a parameter and returns the largest common divisor for those 2 numbers. And the other one was isPrime, which tests whether a number is prime, returns true or false. But then we also added another method that printed out the first 50 of them. So with that, that's all for this video. Thanks a lot.